Hello, everybody. Is weather a thing? Yes, weather is a thing. And we have a lot of products and services to help us as pilots determine what the weather is and what it might be. In fact, I wonder, is there a regulation that says I need to check the weather prior to flight? Absolutely there is. I hope you're familiar with it. It is FAR 91103, and it's usually referred to as pre-flight action. Now, when we talk about weather products, I want you to think in two broad categories. Observed products, which are exactly what it says, they are observed, or forecast products, again, exactly what it says. These are what we think will happen in the future. Well, welcome back everybody to the Epic Flight Academy. I'm your host, Mike Thompson. Please hit that subscribe button down below. And you are joining us today for weather products. Now, in order to be successful in the course, as you know, there are three keys. Number one, please be studying this content in Epic's online instrument rating course. And number two, watch yours truly in these videos. And number three, please review all of this one-on-one with your flight instructor. In fact, as we move through this video today, I'm going to point out some specific products and times where I want you to work one-on-one with your instructor and look for some real-world applications of some of the things we're about to discuss. So as we walk through weather products, remember, we are going to be the recipient of briefings that help us understand the weather to expect. And these briefings really come in three flavors. And you're going to find these three types of briefings in the AIM Chapter 7. You're probably already familiar with these. These three briefings are the Outlook, the Standard, and the Abbreviated Briefings. Now, that Outlook briefing is when you know that your flight is 6 or more hours away, and you want to get a what? An outlook. Yeah, kind of get a feel for the forecast. The Standard briefing provides the most complete information regarding your flight. And that Standard briefing is to be received within 6 hours of your flight. And then finally, the Abbreviated Briefing. Yeah, that's a shortened version of the Standard briefing, just to kind of bring you up to date, maybe right before your flight or within 3 hours of your flight. Again, Chapter 7 in the AIM will review these briefings with you. Now, there's a technique that I want to recommend to you. And here is one of those areas where you're going to work one-on-one with your instructor. I want you to go out to the Aviation Weather Center website, and you can see an example of that here. And on this Aviation Weather Center website, I want you to find with your instructor the Standard briefing. And I want you to notice, if you look at our excerpt here on the screen, that website parallels exactly what the AIM Chapter 7 tells me will be in a Standard briefing. Now, the beauty of this is that you will click on each of these items, work yourself through that Standard briefing yourself, and then call a briefer and review all of that content and make sure that if you have any questions at that point, you get those answered. Now, as we work through the Standard briefing, you see that one of the first parts of the Standard briefing is a synopsis. Well, here is an example of a surface analysis chart. The surface analysis chart is certainly not our only synopsis tool, but it's a really good synopsis tool. Now, here, for example, I want you to see in a succinct chart how much information could be drawn from the surface analysis chart if you have a little bit of background knowledge in weather theory, which of course was previous videos. So, for example, take a look at the state of Texas here. And imagine we were flying into or out of an airport in northern Texas. Now, look at the surface analysis chart. Try to come up with an idea of what do you think the cloud cover might be? What do you think the surrounding weather might be like? Where do you think the winds might be from? Which direction and how strong? And you can put a lot of that together just by looking at Texas here on the synopsis chart. Or let's go out to the East Coast. Let's imagine we were going to our nation's capital here to Washington, D.C. Now take a look at that surface analysis chart and you can see, based on what is on that chart, frontal positions, pressure positions, isobar positions, and again, start to piece together, what do you think the sky conditions like? What do you think the winds are like? And then go to those airports, get the METAR, and see how close you were. This is a great way to practice your weather theory and interpretation skills. So I want you to do exactly that with your flight instructor, and you will see why I call the surface analysis chart the king of charts. The next chart we want to look at is what we call radar summary, or the RCM chart. The radar summary chart is observed data, and it comes out twice hourly at 15 and 45 minutes past the hour. And you can see an example of a radar chart here. And one key thing to remember here is that it is radar, and radar must bounce off of something. So a key concept here is that radar does not see clouds. It cannot see that water vapor doesn't provide enough signature to reflect that energy back. So if we're looking at this radar summary chart, what do you think that radar is seeing? And if you said raindrops of precipitation, you are correct. That is what the radar summary chart is seeing. The next chart I want you to look at is what we call the low-level significant weather charts. Now, here we have jumped the fence from observed data to this is a forecast chart. And this forecast, this low-level significant weather forecast, is issued 4 times daily. And you can see in our example, the solid red line outlines IFR. The blue scalloped line, marginal VFR. And what outlines VFR? Well, VFR is not outlined. If it's outside of the blue scallop, it's VFR. Now, real quickly, let's review. VFR means 5 statute miles and 3,000 foot ceilings or higher. IFR means 1,000 foot ceilings and 3,000 statute miles of visibility. So what if you had 4 statute miles of visibility or a 2,500 foot ceiling? You're somewhere in between, and that's marginal VFR. 3 to 5 statute miles, 1,000 to 3,000 foot ceilings, which is technically VFR. Now, the next chart that we want to take a look at is what we call a SIGMET. And put it together. The SIG stands for significant. The MET stands for meteorology. So significant meteorological information. Now, SIGMET is an expected occurrence of specified en route weather phenomena that affect the safety of all aircraft operations. Now, these may be issued for severe turbulence, severe icing, a widespread dust storm, sandstorm, or volcanic ash. These SIGMETs represent occurring or expected occurrences within a 4-hour period. And they're valid up to, but not exceeding, 4 hours. Now, related to SIGMETs are what we call convective SIGMETs. So remember from weather theory, where we talked about convection moving vertically and advection moving horizontally. Now, think for a second, what kind of significant meteorology is convective? And if you're thinking of thunderstorms, you got it exactly correct. Convective SIGMETs will be issued for lines of thunderstorms that are at least 60 miles long, an area of thunderstorms that is 40% or greater over a 3,000 square mile area, embedded or severe thunderstorms expected to last more than 30 minutes, tornadoes, hail that is greater than 3/4 of an inch in diameter, and wind gusts greater than or equal to 50 knots. Now, the third type of advisory is called an AIRMET. This is an Airman's Meteorological Advisory, or AIRMET. Now, these are forecasts of en route weather that is hazardous to some, but not all, aircraft operations. Less hazardous conditions than a SIGMET. Now, AIRMETs may be issued when any of the following weather phenomena are occurring or expected to occur over an area, again, of 3,000 square miles or greater. And we've reviewed these in an earlier video, so we'll touch on them just quickly. Tango, Zulu, and Sierra. Tango and turbulence both start with a T. AIRMET tangos deal with moderate turbulence. Zulu deals with moderate icing, and Sierra deals with IFR conditions or widespread mountain obscuration. Now, let's jump to our next chart here, and this is the winds and temperatures aloft. Now, this winds and temperature aloft chart is on the forecast side of the fence. This is not observed, but forecast. Now, if you take a look at our example, you see some blank areas in here. Let's go down the left-hand column and find DEN for Denver. And as you come horizontally across from Denver, you see some blank areas. Under the 3,000 and 6,000 foot column, you say to yourself, what, the wind's not blowing in Denver? Wind forecasts are not issued for altitudes within 1,500 feet of a location's elevation. And temperature forecasts are not issued for altitudes within 2,500 feet of the location's elevation. So if you're familiar at all with Denver, you know that its elevation is approximately 5,000 feet, and that's why those spaces are blank. Now, if you see an area on the chart that says 9900, that means the winds are light and variable, speeds of less than 5 knots. Now, if you see a larger number that doesn't seem to quite make sense, for example, in our graphic here, if you look in the top right corner, at 39,000 feet, we see 742755, and we're thinking, what's that? Just remember, minus 50 plus 100. By that I mean that first number, 74, you minus 50, and that leaves me with 24. That's the direction, 240 degrees. That second number says 27, now plus 100. So that's 127. So my 742755 is winds 240 degrees at 127 knots at minus 55 degrees Celsius. That's winds and temperature aloft. Now, speaking of going aloft, we are also very interested in forecasted icing. Now, there's two charts that we use for this, and you can see those both on the screen. On your left, in shades of blue, is the maximum icing severity chart. The chart on the right is showing freezing level altitudes, and that's the chart with the various colors from purple to blue to yellow to red. Those colors represent different altitudes of the freezing level. Now, the next aviation report we want to review should be very familiar to you. This is the METAR. So we won't go into it in great detail. Again, here, I want you to review with your flight instructor. But imagine you're flying into an airport and you say to yourself, well, you know, I want to get this airplane safely on the ground. What am I really interested in? I'm really interested in the wind direction and velocity. I'm really interested in the sky cover. You know, what kinds of clouds, how high are they? Is there a ceiling? And what's the visibility? Now, if you take a look at the METAR, that is the primary information in the METAR. Wind direction and speed, visibility, and then the sky condition. Now, we follow that, of course, with temperature, dew point, pressure, and additional remarks. That's the METAR. Again, in review, now we're looking at the TAF. Now, notice how we've jumped the fence here. The METAR is an observed product. The TAF is a forecast product. The TAF does not exist yet. So again, review this with your flight instructor, but here we're going to see the issue date and times, wind direction and velocity, visibility, and sky cover. Some of the primarily important features to a pilot flying into an airport. Now, as you come down the left-hand side of this TAF, I want you to notice most of these lines start with FM. FM means from. And what the meteorologist is trying to tell you here is that from this certain time, you can expect the conditions shown on this line. Now, notice the line that says tempo. Here the meteorologist is saying, now here is a temporary condition that may exist at that airport during this time. Now, not shown in our example is becoming. Now, becoming and from are very similar. The difference being that if it says FM for from, that means these conditions are changing rapidly and in approximately an hour. Now, folks, in terms of meteorology, a big change within an hour is fairly rapid. If it says becoming, then it means these conditions are changing gradually, probably 2 hours or maybe more. So again, take a look at TAFs in your area and review some of this with your flight instructor. Now, I want you to start to talk with your flight instructor about these TAFs specifically and how these forecasted winds, visibility, and cloud cover is going to affect your choice for alternate airports. And if you stick with us for the next video, you're going to see us talking about alternate airport selection. Now, the next report we want to get to are what we call PIREPs. These are pilot reports. Now, these are technically observed reports because it is literally the pilot looking out the window and radioing back to flight service or ATC exactly what they're observing. Now, can you imagine how that might be very valuable to fellow pilots? I sure can, and these PIREPs are extremely valuable, which is why we and the aviation community at large encourage you to please send PIREPs. Now, I know as a flight instructor that one of the reasons a lot of pilots are hesitant to send PIREPs is because they don't remember all of the technical specifics for the order of how things are supposed to appear. I think I studied that in ground school, but I hear I'm flying the airplane. I don't remember. I'm here to tell you, please don't let that worry you. Here's all you need to do. Report your position, time, and altitude. Of course, they're going to ask you for the type of aircraft you're flying, and I sure hope we know the type of aircraft we're flying. So you're going to report your position, time, and altitude, and then just look out the window, tell them exactly what you see, and don't worry about it because they will put it into the proper format and disseminate that for your fellow pilots, and you've made a huge contribution to their safety and their knowledge of the local weather. So please file pilot reports. Now, finally, I want you to look back at some of the services and products we've talked about and notice that maybe other than Winslow Aloft and some of the surface analysis charts, a lot of our products are really kind of airport-based, in particular METARs and TAFs. So if I'm flying across Florida here, and you can see my course as I cross this beautiful state of Florida, what will I expect to find in between my departure and destination airports? Well, folks, this used to be covered by what we call the area forecast. Now, not too many years ago, the government has come up with what we call the GFA. And you see an example of that here. This is the graphical area forecast, or the GFA tool. And I want you to go out to Aviation Weather, and I want you to work with your flight instructor and explore what a powerful tool this GFA graphical area forecast is. And if you look across the bottom of our example, and you'll do this with your flight instructor, there are different options you can click on, click off, and get a real good picture of what the weather is going to look like between your departure and destination. So folks, that just about wraps up our presentation of weather products. Thanks for joining us, and join us next time.